The Subaru SVX automatic HVAC system is an electronically controlled system designed to provide full climate control and passenger comfort during any driving conditions, hot or cold. The air conditioning and heating system components within the automatic HVAC system operate under the same basic principles that govern all Subaru air conditioning and heating systems. In order to properly diagnose and troubleshoot the system, it is necessary to understand the basic system components and operation. The basic mechanical parts look and operate like components used on other Subaru models. The air conditioning compressor is an exception. The DCW17BE variable displacement compressor is unique because the displacement or pumping capacity is electronically varied. Despite the unique internal capabilities of the DCW17BE, it is still an engine-driven compressor, and the mechanical operations it performs are the same as other air conditioning compressors. That is, to compress and circulate refrigerant through the AC system. At the heart of the system is an onboard processor or automatic control unit. The Auto Control Unit, or ACU, has control of compressor displacement, air intake, air volume, air temperature, and air outlet modes. These 5 areas are controlled to maintain passenger comfort and safety. The system is designed with the concept of input, evaluation, and output. 4 input sources provide information to the ACU: sensors, actuators, the control panel, and the Vehicle Electronic Control Module, or ECM. HVAC sensors consist of 5 electronic thermistors and 1 light-sensitive diode, strategically located throughout the vehicle. Thermistors are electronic devices which alter resistance values according to temperature. The light-sensitive diode is a device designed to generate voltage according to sunlight intensity. The passenger compartment sensor measures air temperature as it is drawn across the sensor through the aspirator tube. The evaporator sensor measures the air temperature as it leaves the evaporator core. Refrigerant temperature is detected as it enters the evaporator core by the refrigerant sensor. The water temperature sensor measures the temperature of the heater core. The ambient sensor detects outside air temperature as it enters the vehicle grille. The resistance of each of these thermistors increases as the temperature decreases. The light-sensitive diode, or sun sensor, produces an increased voltage as sun load increases. Another type of input to the ACU comes from 3 separate actuator motors, which drive various doors throughout the system. Intake door position is provided to the ACU through the position sensing contacts within the actuator. The mix door and the mode door actuators contain a potentio balance resistor, which supplies the ACU with exact door positions. The ACU receives inputs from the control panel regarding the operator's desired conditions. In the auto mode, the ACU is given full control over the 5 control points: compressor displacement, air intake, air volume, air temperature, and air outlet mode. Manual selections can also be independently made through the control panel. The compressor is disengaged in the economy mode. Air intake can be forced to the recirc position. Blower speeds can be manually selected. Desired temperature can be selected from 65 to 85 degrees Fahrenheit, or 18 to 32 degrees centigrade. Some air outlet modes can be manually selected. For instance, in the vent mode, the air outlet door is driven to the dash vent position. It should also be noted that the remaining 4 control points are driven to fixed positions. Compressor operation is cancelled. Air intake is driven to the fresh air position. The air mix door is driven to bypass the heater core, and the blower motor speed is driven to medium. The service manual describes all control panel input functions in detail. When approaching an engine overheat condition, the vehicle ECM provides a suggested compressor displacement input to the ECU. The information collected by the various input devices must be evaluated by the ECU to determine the required output to the 5 control points. The ECU receives input in 2 ways: pulse signals or voltage signals. Pulse signals received by the ECU are generated by the control panel regarding the operator's desired response, or the vehicle ECM regarding suggested compressor displacement. A 5-volt reference signal is sent from the ECU to all the sensors and actuators. These devices alter the signal based on temperature changes, sun load, door position, or by completing a ground circuit through the position sensing contacts. Using programmed logic, the ECU combines the values received from all the input sources to develop a single numeric value, or composite signal. Based primarily on the composite signal, the ECU will drive 4 of the 5 areas of control to the required performance level. The composite signal controls air intake door position, blower motor speed, air outlet position, and the air temperature door position. The compressor displacement output is developed from either the evaporator or refrigerant sensor inputs, not the composite signal. The DCW17BE variable displacement compressor is a 5-cylinder wobble plate compressor. The angle of the wobble plate determines the stroke of the pistons. Longer strokes equal greater capacity. Shorter strokes equal less capacity. Displacement can be varied from full 100% capacity to a minimum displacement of 5%. The compressor solenoid valve is an infinitely variable bleed valve, which, based on the amount of amperage received from the ECU, controls wobble plate chamber pressure. When open, the solenoid valve provides an escape route for compressed refrigerant, which prevents wobble chamber pressure from rising. When less compressor capacity is required, the ECU provides an amperage signal, which varies from 0 to 0.6 amps to the compressor solenoid valve. This variable amperage closes the solenoid valve, causing wobble chamber pressure to increase. Increased wobble chamber pressure on the backside of the pistons forces the wobble plate and pistons to a shorter stroke. As amperage to the solenoid valve is decreased, the valve begins to open, and wobble chamber pressure begins to escape, allowing the wobble plate and pistons to be driven to a longer stroke. The air intake door can be driven to 3 positions: 100% fresh or outside air, 100% recirculated interior air, or 20% fresh mixed with 80% interior air. To control the blower motor circuit, the ECU manages 3 different components. Source voltage to the blower motor is controlled by the off relay. Specific voltage signals from the ECU to the power transistor control the amount of voltage allowed to the blower motor circuit. Higher voltage signals result in greater blower speeds. When high blower conditions are required, the ECU energizes the high blower relay, which permits full system voltage in the blower motor circuit. The air mix actuator enables the ECU to manage air temperature. Airflow is diverted to bypass the heater core completely in maximum cooling modes. Pass only through the heater core in maximum heating modes, or any combination for intermediate temperature control. The potentio balance resistor is used to inform the ECU of the specific mix door position. The ECU then drives the bidirectional actuator to the required position. The air outlet actuator enables the ECU to control air distribution. Airflow is directed to defrost, dash, floor outlets, or any combination of the three. This actuator, like the mix actuator, uses the potentio balance resistor to inform the ECU of the specific door position. The ECU then drives the bidirectional air outlet actuator to the required position. The ECU does not directly control compressor on and off operation, but sends an output signal to the ECM, requesting compressor operation in the auto and defrost modes. In summary, the SVX automatic HVAC system operates with the concept of input, evaluation, and output. At the heart of the system is the auto control unit. The ECU has control of compressor displacement, air intake, air volume, air temperature, and air outlet modes. Some operating conditions, such as hot and cold startup, or extreme ambient temperatures, may have an effect on certain system functions. Always refer to the service manual for additional information. Automotive air conditioning